you again for reminding me because it would have gone over. All right, so y'all, what we're going to talk about in 4.2 is this idea called binomial distributions. Okay, y'all, think about the prefix bi. Like you have a bicycle. Bicycle means we have how many wheels? Two, right? Okay, so we're going to talk about binomial experiments here. Okay, so a binomial experiment is a probability experiment that satisfies the conditions. So the first one says the experiment is repeated for a fixed number of trials, where each trial is independent of other trials. There's only two possible outcomes for each trial. The outcome can be classified as a success or as a failure. The probability of a success is the same for each trial, and the random variable X counts for the number of successful trials. Okay, so y'all, we have some symbols that we're going to use. N is going to stand for the number of trials. P is going to stand for the probability of a success of a single trial. Q is the probability of a failure in a single trial. And then X is going to stand for the number of successes in however many trials we do. Okay, so let me see if we can kind of go through something here, y'all, to make this hopefully a little bit easier to understand. Okay, so I have an example here, and it says decide whether the following is a binomial experiment. If it is, specify the values of n, p, and q, and then list the possible values for the random variable x. And if it's not, explain why. Okay, so let's take a look here. It says about 50% of babies born with a certain ailment recover fully. A hospital is caring for 6 babies born with this ailment. The random variable x represents the number of babies that fully recover. Decide whether experiment is a binomial experiment, and if it is, identify a success, specify the values of n, p, and q, and list the possible values for the random variable x. Okay, so let's take a look here, y'all. I'm going to try to see how we can determine if this is a binomial experiment. Okay, so the number one, it says the experiment is repeated for a fixed number of trials. What we mean by that, y'all, how many babies are they looking at right now? 6 babies, okay? So y'all, we have 6 babies that are born here. They all have some kind of ailment, but we know that half of them recover, okay? And so what we're gonna do is we're gonna offer them this treatment, and we're gonna see how many of them recover. So we do have a fixed number of experiments, okay? Second thing, y'all, there are only 2 possible outcomes. Either this baby is going to recover, or they're what? Or they're not going to recover, right? Whatever this ailment happens to be. So those are the only 2 possible outcomes, right? Either they recover from whatever illness they have, or they don't recover. So far, step number 2, we're good, okay? The probability of a success is the same for each trial. What's the probability that these babies are going to get better? 50%, right? So half of them are going to get better, half of them are not, whatever it happens to be. But the likelihood that they're going to be better is still 50% every single time, okay? So y'all, is this a binomial experiment? Yes, because we satisfied all the conditions. The random variable x counts the number of successful trials. So y'all, we have 6 babies. So we're going to figure out what that part means. So I'm just going to kind of zoom out here, and I'm going to say, is this a binomial experiment? We're going to say, yes, it is. Okay. What is a success in this treatment? So y'all, we have babies that are born with whatever it happens to be. The success is that they do what? The baby recovers, or the baby doesn't recover. I'm not worried about this part because we already knew it was a binomial experiment. What do you think the success would be? The baby recovers. Okay, so we're going to say, look, the baby recovers. Okay. Y'all, I'm going to scroll down. I know, I'm sorry that the copies kind of went to the next page. Specify the value of n. Do y'all remember how many babies we were looking at here? 6. That's going to be my n, y'all. Okay. Specify the value of p. Y'all, p is the likelihood or the chance that this baby is going to get better. How many babies did we say would get better? 50%, right? Okay, y'all, when we're going to do our values for p, we're going to write it as a decimal. Does anybody remember how to write 50% as a decimal? 0.5. So my P is going to be 0.5. Now, the next part, y'all, is going to be Q. Q is the probability that the baby does not get better. Okay, let me give you a formula, y'all, for the number Q. The way we're going to find the value of Q is we're going to take 1 minus P. So, y'all, I'm going to do 1 minus 0.5. So if I take my calculator and go 1 minus 0.5, we still get 0.5, right? So that means half the babies get better and the other half do not, okay? Now, y'all, for the last part here, it says list the possible values for the random variable X. So remember, we have 6 babies. They all have some kind of ailment. We're trying to get them better. The X is going to stand for how many of the babies could get better. So y'all, what I want to think about here, how many of the babies could get better? Let's think about the possibilities. Is it possible that no babies got better? It's possible, right? I mean, it's possible that none of the babies get better. It's possible that 1 baby is going to get better. It's possible that 2. It's possible that 3. When would I stop, y'all? At 6. So from 0 to 6, either none of the babies got better or all the way to 6 of the babies got better. Y'all, which one of those would I choose? First, second, third? I know I'm not going to do the last one because it is my number. Second one, right? So either none of the babies got better or all the way to 6 of them got better, right? And that's how we're going to kind of go through some of this stuff here. And y'all, one of the things we're going to do in a few minutes is we'll figure out how do we actually find the probability that 3 babies got better or 2 babies got better, whatever it happens to be. We'll do that in a minute too, okay? Y'all, we're going to do the same thing here. We're going to figure out if this is a binomial experiment, okay? So let's take a look. It says a survey asked 1,400 workers, has the economy forced you to reduce the amount of vacation you plan to take this year? So inflation is up, right? Things cost more. Has the economy said, hey, you know what? I don't know, right? Telling the family, hey, I don't know if we can go on vacation this year because everything has gotten more expensive. That's what they're basically asking me to figure out, okay? Now, look what it says. It says 48% of those who surveyed said they are reducing the amount of their vacation. Okay, I'm going to start reading a little bit more, y'all. 20 workers. Okay, so now we're looking at 20 people participating in the survey are randomly selected. The random variable X represents a number of workers who are reducing the amount of their vacation. Decide whether the experiment is a binomial experiment. If it is, what's the success? Specify the values of N, P, and Q. List the possible values. Okay, so remember, y'all, if we want to know if this is a binomial experiment, we're going to repeat this for a certain number of trials. So the number of trials we're going to do, y'all, is with those 20. So we're going to ask 20 people the same question, okay? The second part of figuring out if it's a binomial experiment, y'all, says there's only 2 possible outcomes. So if I come back and over here, y'all, either you're going to reduce your vacation or you're not going to reduce your vacation, right? Those are the only 2 options that we got. So step number 2, we're good. Step number 3, the probability has to be the same each time. Well, when we look at this, y'all, what percent of those people said, yeah, I have to reduce my vacation? 48%. The probability is going to be the same every time. So y'all, again, we're going to have a binomial experiment. Now, if we want to know what the success is, remember what the question that they're asking us. The question they're asking us, I have it here highlighted, has the economy forced you to reduce the amount of vacation? So, y'all, if we're selecting people, and suppose I ask Paolo, and Paolo tells me, yes, I've had to reduce my vacation. I know we would say that doesn't seem like a successful thing to do, but that's the question we're asking. So that's going to be my success. Selecting a worker who is reducing their vacation, because those are the people that we're looking for. So y'all, I'm going to go ahead and come over here and I'm going to select my first one. Boom. Okay. I'm going to scroll down a little bit further. Y'all just going to kind of take a quick look here. How many people were we looking at? How many people did we actually select out of that big group? 20, right? You say, why 20? Because it tells me right there, we looked at 20 people. So y'all, right here, my N is going to be 20. Okay, now let's find the probability of a success. Does anybody remember what percent of people said they were going to have to reduce their vacation? 48%. Okay, so y'all, as a decimal, everybody agree? 0.48? Okay. Now, let's find our value for Q. Remember, y'all, my formula for Q is going to be 1 minus P. So, y'all, if we go 1 minus 0.48, we should get 0.52. Y'all remember the other day when I said, hey, if Tim Smith said there's a 48% chance that it is going to rain, then we would say that means that there's a 52% chance that it's not. That's really all we're doing right there, okay? So y'all remember, we were looking at 20 people, right? We were looking at 20 people. So when we select those 20 people, it's possible that all 20 said I have to reduce my vacation. And it's possible that nobody said we'd have to reduce our vacation. So we're going to pick our numbers going from 0 to what? 0 to 20, right? So y'all, we're going to select that third one right there. Okay. Boom. And let's put a little check mark right there on this guy. Now, y'all, for my next part here, we are going to use a binomial probability formula. And I have that right here. And I wrote it down on the next page, and we'll figure out how to do all this stuff again. But again, remember, N stands for the number of trials. P is the probability of a success. Q is going to be the probability of a failure. X are the number of successes and N trials. And N minus X would be the number of failures. Okay, so let me explain how we're going to do some of these problems here. So I got a problem here for us to do, y'all. Let's see if we can figure this thing out. I'm going to start reading through my question. And it says 39% of adults have very little confidence in newspapers. We randomly select 8 US adults, find the probability that the number of who have very little confidence in newspapers is part A exactly 6 and part B exactly 2. Okay, so let's do a couple of things here, y'all. Let's find some values first. Let's figure out how many people are we asking in total. Anybody know? 8. Good. Okay, let's find our value, y'all, for P. What percent of folks think that newspapers are not too accurate? 39. Very good. Now, y'all, let's see if we can find a value for Q. Remember, y'all, Q is going to be 1 minus P. So my value for Q, y'all, is going to be 1 minus 0.39, 0.61, right? Okay. Okay. So y'all, now I'm going to come back to my question here, and it says, can we find the probability or find the number who have very little confidence in newspapers exactly 6? Y'all, this means that my value of X is going to be equal to 6. Okay. So y'all, I have a little formula for us right here, and we're going to use this formula, okay? So look, we're going to say the probability that 6 people out of those 8 feel that newspapers are not too accurate, we're going to do this part right here. So look, let's look at the first part. What do we say our value of N was again? 8. So we're going to go 8, choose X. X in this case, y'all, is 6. Okay. Right next to it, y'all, we're going to put our value of P. Our value of P, we said, was a 0.39. We're going to raise that to the power of X. And we said, again, X was 6. And then right next to that, y'all, we're going to write our value of Q, which was a 0.61. I'm just going to move this out of the way a little bit where I got some room. Oops, sorry. And my formula, my power up here, y'all, is going to be N minus X. So 8 minus 6. But by the way, what is 8 minus 6 anyway? 2. Okay, so let's just go like that. Now, y'all, this right here, my friends, is what I'm going to type in on my calculator. Okay. So, y'all, I want us to get familiar with this stuff because I think one of the hardest parts is just remembering, like, man, how do I do this on my calculator? Okay. So, y'all, I'm going to give you this formula right here. We're going to go through slowly. So, exactly what I wrote is exactly what I'm going to type in on my calculator. First thing I see is parentheses. We're going to go 8. Remember, y'all, we're going to go to math. We're going to go to probability. And we're going to choose 6. So, we're going to do the number 3 because it has the C, right? Okay. Close that up. Right next door to that, y'all, we're going to take 0.39 and we're going to raise that to what power? Power 6, good. And then right next to that, y'all, we're going to do 0.61 and we're going to square that. You can either hit the square button or you can go to the power 2, either way. And I'm going to hit enter. And y'all, I think in these problems, they're asking me to round. Yeah, they're asking me to round to 3 decimal places. So y'all, I got a question for you. 0.036, 0.037. 0.037. Very good. So look, y'all, right here, we're going to put 0.037. Okay. All right. Y'all, for the next one, we're going to do the same thing. The only difference now is that they're asking us what's the probability that only 2 people feel that the newspapers are, we don't have too much confidence in newspapers. So the only thing I'm going to do here, y'all, is I'm going to change my value of X from a 6 now to a 2. Everything else is going to stay the same. So remember, our N is still 8. So we're going to go 8, choose 2. Then we're going to take our value of P, which was a 0.39. We're going to raise that to the power of 2. And then we're going to take our value of Q, which was a 0.61, and we're going to raise that to a power of N minus X. So that should be 8 minus 2. But we know that 8 minus 2, y'all, is the same thing as 6, right? Now, yo, this idea here is going to work on whether you're using the regular calculator, y'all, or you're using your calculator app. Okay, I just want to show you guys something. Yo, if I go second and enter, it's going to type in exactly what we typed in right before. And the reason I'm doing this, y'all, it's just going to save me a little bit of time. Look, I don't want 8 choose 6. I want to have 8 choose 2. So I'm just going to use my little arrow. I'm going to scroll back. And instead of me having a 6 right there, we're going to put a 2. Okay. I'm going to come back over here. And on my 0.39, instead of having a power of 6, I want a power of 2. And on my 0.61, instead of me having a power of 2, I want to have a power of 6. And I'm going to hit enter. And again, y'all, I'm going to go to 3 decimal places. So we'd say 0.219. So y'all, that little trick of just doing second enter, it's just another way of like without you having to retype everything in, right? If yours isn't working, by all means, you're just going to retype everything in again, right? But again, what I'm showing you guys is this is basically how the formula works, okay? All right, so look, y'all, let's scroll down a little bit further. And we're going to do another problem. We're going to construct what we call a binomial distribution. Okay, so we did probability distributions on Tuesday. We're still kind of basically doing the same thing. So it says 34% of voters think that Congress should help write standards for school food. You randomly select 6 voters and ask them whether Congress should help write standards. The random variable X represents the number of voters who think Congress should help write standards. Okay, so y'all, let's see if we can figure this problem out. We're gonna go through really slow, just make sure that everything is all good. Okay, so remember, y'all, our N is the number of people that we surveyed. How many people did we ask here? Does it tell us how many voters we asked? 6, right? So if you look right here, it says we randomly selected 6 voters. Okay, now the percent or the probability that people want Congress to help us write some food standards for school food was what percent? 34. So y'all, 34%. As a decimal, everybody agree? 0.34? Okay, let's find our value of Q. Remember, y'all, Q is just 1 minus P, right? So if I say, what's 1 minus 0.34, 0.66, okay? Now, what we're going to do now, y'all, is we're going to fill out this probability distribution, okay? So the first part here says, suppose we asked those 6 voters, what's the probability that none of them said, hey, we think Congress should get involved in this thing here, okay? So look, y'all, I already have the formula set up. So again, I'm going to take my calculator, y'all, and I'm going to type in exactly what we got right here. Let me clear all this out. So y'all, again, I'm going to go parentheses. We're going to go 6 math, probability. We're going to choose none of them because we're saying none of them are going to do this. The probability that people want this is 34%. So we're going to say 0.34. But none of those people that we chose wanted them to do this. The probability that it doesn't happen is 0.66. And if nobody wanted the Congress to get involved, then that means that all 6 didn't want them to get involved, right? We're going to hit enter. And y'all, again, I'm going to go to 3 decimal places here. So 0.083. Okay. Now, y'all, we're going to play this game, and we're going to go all the way down to 6, okay? So notice, y'all, when we do this the next time, when we find the probability of 1, remember, we're going to have 6 choose 1. And then we're going to say 0.34 to the power 1 and 0.66 to the power. If one person wants this to happen, then that means that the other 5 don't, okay? So y'all, again, just as a, again, if you want to do it like this, y'all, you definitely can. Hit second enter, and then let's just go back and change some of those numbers. So I'm going to change this 0 to a 1. I'm going to change that 0 to a 1. And I'm going to change this 6, my friends, to a 5. We'll hit enter, and I'm coming up with 0.255. Okay. Now, y'all, I'm going to do the same thing again, but we're going to choose 2. Okay. And so let me just come back here. Let's do this. And let's change this guy to a 2. Let's change this one here to a 2. And let's change this fella over here to a 4. And I'm coming up with 0.329, right? Okay. Probability of 3 people wanting this to happen. 6 choose 3. 0.39 to the third. 0.66 also to the third. Let's go enter. Let's come back here. Change this one to a 3. And this one to a 3. And one more time to a 3. And y'all, I'm coming up with 0.226. Okay. And again, y'all, I'm going to do the same thing for 4. So 6 choose 4. 0.39 to the fourth. 0.66 squared. And let's do that. 4, 4, and 2. Okay, and 0.087. Okay. So now we have 6 choose 5. 0.39 to the fifth. 0.66 to the 1. Okay. All righty. And let me scroll back again, y'all. Let's put a 5 right there. Let's put a 5 over here. And let's drop a 1 right there. Okay, so 0.018. And finally, my friends, one last time, probability that all 6 want this to happen. Okay, so let's fix this. Here we go. Remember, that's a 6. This one is now a 6. And the last one should just be a 0. And let's hit enter. And 0.002. Okay, so we were able to fill out our probability distribution. Y'all, just a heads up, if we were to take 0.083, 0.255, 0.329, 0.226, 0.087, 0.018, 0.002, add them all up, probability is going to add up to 1, right? Because these are all the possibilities, right? So if we were to add all those numbers up in the red on my probability column, y'all, that should add up to 1. Now, the reason why we did this, y'all, is we can come back over here and we can start to answer some questions. So the first part says, hey, what's the probability that exactly 3 voters think Congress should help? So y'all, all I'm going to do is I'm going to come back over here. And if we're looking for the probability that 3 out of those 6 say Congress should help, we're going to say 0.226, right? Okay, now, what do you all think? Find the probability that at least 3 or voters think that Congress should help. What do you think at least 3 means? Do you think at least 3 means 3 or less, or do you think at least 3 means 3 or more? 3 or more, right? At least 3. Like if I said, look, I want to have kids and I want to have at least 3 kids. That means if I didn't have any kids, I'm not happy. And if I only got 1 kid, I'm not happy. If I only got 2 kids, I'm not happy. I'm not going to be happy until I have 3 or more, right? So y'all, if we're going to do this, we're going to find the probability of 3, of 4. When would we stop, y'all? At what point would we have to stop? At 6, right? Because we only asked 6 people. Very good. So look, y'all, let's take those numbers and let's Adam and Eve, right? So look, 3 was 0.226 plus 0.087 plus 0.018, oops, 18, okay, plus 0.002. And y'all, I'm coming up with 0.495. Boom. Okay. And now, if we said find the probability that fewer than 3, y'all, what do you think fewer than 3 would mean? Anybody have an idea? What do y'all think fewer than 3 would mean? Would it be 3 and less, or would it be 2 and less? If it's fewer than 3, think about fewer than 3 to be less than 3. What numbers would be less than 3? 0, 1, and what? 0, 1, and 2, right? Now, y'all, right now, let's do this. Right now, didn't we just add up these folks? Right? Those are the numbers we just added up. Okay. I want to show you 2 things. Let's go ahead and add these folks right here. So y'all, I'm going to take my calculator and I'm going to say, let me clear everything here. Let's go 0.083. Oops, sorry. 0.083 plus 0.255 plus 0.329. Okay, we add those together, coming up with 0.067. Is that what anybody else get the same thing? 0.667. Okay, boom, there we go. .667, sorry. All right. Okay. And then they're asking us right here, y'all, and I'll show you how to do this kind of stuff in a second, but it's asking us to identify the random variable X that may be considered unusual. Unusual, y'all, just means that my probability is smaller than 0.05. So if I were to come back over here, are there any numbers here, y'all, in my list that are smaller than 0.005? And was it 005 or 05? I'm sorry, 0.05, sorry. Right here, boom, 0.05. Were there any numbers that were smaller than 0.05? What, 5 and 6? Aren't those numbers smaller than 0.05? And you say, why do you mean smaller than that? Because look at those numbers. They're smaller than 0.05, right? And the way I'm doing that, y'all, I'm just looking at my second digit, and those second digits are smaller than 5, right? Because my first one's got to be 0. So x equals 5 and x equals 6 are what we call the unusual values. Okay, so y'all, there is a way that we can do this setup on our calculator without having to do that formula, okay? And the way we're going to do this, y'all, we can start by hitting the second button and then the button called vars, and we're going to get to what we call our distribution, okay? And we're going to do something called our binomial PDF. So I'm going to show you guys how we can do that on this next question here, okay? And I'm going to show you how we can do, I mean, we can still use the regular formula, but there's just, the calculator has a shortcut in how to get to this, okay? So let's take a look and let's see if we can figure this thing out. It says 30% of consumers prefer to purchase their electronics online. We randomly select 8 consumers. Find the probability that the number of consumers who prefer to purchase their electronics online is A, exactly 5, and we'll go through each of them as we go down. Okay, so let's do it like this, y'all. Let's figure out our value for N. How many people did we survey here? 8. So there's my N. Let's find our P. So our P, how many people wanted to get their electronics online? Any 30%, right? How do we write 30% as a decimal? Anybody remember? 0.3, right? Good. Now, y'all, we don't actually have to do the Q part here. The only thing we need to figure out is what is our value for X? And in this case, it says who want to purchase their electronics online is exactly 5. We're going to say X equals 5. Now, y'all, this is what I'm going to use. On my calculator, I'm going to get to this thing called binomial PDF. I'm going to show you how I'm going to get there right now. We're going to put our number of trials, which is my N, 8, comma, we're going to put our probability, which is a 0.3, comma, and then we're going to put our value of X, which in this case is going to be 5. Now, again, y'all, if you prefer using the regular formula, we can always do that too. This is just an alternative. So look, let me get my calculator going. We're going to clear everything. Y'all, we're going to hit the second button and the button that says VARS or VARS, okay? And, sorry, second and VARS. Now, y'all, I'm going to scroll down on my calculator until I see something that says binomial PDF. Here it is. It's my 10th one, at least on my calculator, okay? So y'all, I'm going to hit enter here. And just like I wrote here, we're going to write the same thing. We're going to go 8, comma. My comma, y'all, is right above my number 7, okay? I'm going to go 0.3, comma, and then the number that we're looking at is 5. Okay? And we're going to hit enter. And again, y'all, I'm going to go to 3 decimal places, and I'm coming up with 0.047. And that's what we got, okay? And it's just another way of doing it, y'all. Remember, we could always use our regular formula by saying, look, we have 8, we're going to choose 5. The probability that people want this to happen is 0.3. We're picking 5 of those. My value of Q, y'all, would be 7, and this number would be 3, and I'm going to get the same exact answer, okay? This idea of using this binomial PDF, it just helps me do it a little bit quicker, okay? Now, let's take a look at the next one, y'all. It says, find the probability that the number that prefer to purchase their electronics online is more than 5. So, y'all, if we're looking for more than 5, does everybody agree that we would be looking at the probability of 6 plus the probability of 7? Where would we stop? At 8, right? So let's do it like this, y'all. Let's find the probability of 6. Let's find the probability of 7. Let's find the probability of 8. Now, remember, the only thing I'm going to do here, y'all, is I'm going to change in each one of those. I'm going to change that 5 to a 6, a 7, and an 8. I'm going to write down my numbers and add them all up. Okay. So look, I'll come back to my calculator. I'm going to hit second enter again. And I'm going to change that 5, to a 6. And that number, y'all, is a 0.010. Okay. Let's do this again. Let's change that 6 to a 7. When we change that to a 7, y'all, I'm coming up with a 0.001. And let's do this one more time. And let's change that 7 to an 8. Okay, here we go. And whoa, check this out, y'all. Did anybody else get that on your calculator? Okay, so y'all, when my calculator gives me a number like this, this is what we call scientific notation, okay? Scientific notation, y'all, is a way to describe numbers that are either really, really big or really, really small. This is a really small number. I'm going to show you on the side what this means. When we have something like this, 6.56 something or another, 561, and it has that little e to the negative 5, what they really mean, y'all, is that this is 10 to the negative 5, okay? What we're going to do, y'all, is we're going to take our decimal place right here, and we're going to move it 5 spaces to the left, okay? So look, y'all, I'm going to go, that's 1. That's 2. What do you think I'm going to have to put here? A 0. Okay. Boom. That's 3. Another 0. Boom. That's 4. Another 0. Boom. That's 5. That's another 0. Okay. So look, y'all, if we're going to go ahead and go to 3 decimal places, 1, 2, 3, should I do anything with that 0 there or no? What do you think? Look at the number to the left of it, right? We can say, look, why don't we go to 4 decimal places in this case, and let's make that a 1. So we'll have 0.0 and a 1, something like that. Does that make sense? That's all it's telling me, okay? So if it gives me that kind of a negative number, means they're going to move your decimal space, that number of spaces to your left. So look, y'all, let's come back over here. We're going to put that. Now I'm just going to add those numbers together, y'all. Okay, so let's clear this out. 0.010 plus 0.001 plus 0.123 and a 1. And that's what I'm coming up with. Again, y'all, I think they are asking me to round to 3 decimal places. So at 0.011, and that's what we're going to write right here. Okay. All righty. Y'all, part C says find the number of people that prefer to purchase electronics is at most 5. Sorry, y'all, at most 5. This should say 5 right here. Sorry about that. At most 5. At most 5 means 5 or less. So y'all, if we were going to do 5 or less, we'd have to find the probability of what? 0, of 1, of 2, of 3, of 4, sorry, 0, 1, 2, 3, 4, and 5, right? But we actually have to do 6 of them because we got to do 0 and then 1, 2, 3, 4, 5. Now, y'all, there is a way to do this on the calculator without having to find every single one, okay? So just to give you, again, just to give you an idea, we need to find the probability of 0, of 1, of 2, of 3, of 4, and a 5. Now, instead of us having to find each of those numbers individually, there is something called the binomial CDF, and it works the same way, okay? We're going to do our value of n, we're going to put our value of p, we're going to put our value of x. Now, you might say, but which is the x that I use? The x we're going to use, y'all, is going to be the biggest one that we have. Binomial CDF says we're finding the binomial distribution for a cumulative thing. everything from the beginning all the way until whatever our last number is. That's what the letter C stands for, cumulative, okay? Like we're adding them all up. How am I going to do this in my calculator? Simple, guys. Look, we're going to clear this out. We're going to go second. We're going to go vars. We're going to scroll down till we see binomial CDF. That is my 11th one, okay? I'm going to hit enter here. Now remember, our n was still the number 8, comma. Our probability was still 0.3, comma, and we're going to stop at 5, okay? And what I'm coming up with here, y'all, 0.989. 0.989. And that's how I'm able to find my probability for everything between 0 and 5, okay? We were able to find all of those right there, and we got our answer. Yes, ma'am. Yes. Okay. So let's do it like this. Let me see. Let me scroll back up here. Okay. So like in our case, trials, remember that's my trials is my value of n. So in that case, we put 8. Our p was our 0.30, right? And then my x is going to be whatever particular value I'm using. Does that make sense? Excellent, excellent. Now, guys, I want to show. I'm glad you asked that. Now, guys, I want to show you something here. When we did parts B and part C, when we did part B, we found a probability of 6, 7, and 8, right? When we did part C, we went from 0 all the way to 5. Now, the only options we can go, I mean, my total number would be from 0 to 8, right? From 0 to 8. Remember what we said? If you were to take all those probabilities and add them all up, remember what number we should get? We should get 1, right? So another, again, just kind of giving you an idea here, y'all. I know that if we wanted to find from 0 to 5, right? I know that if we would have gone from 0 all the way to 5, and then 6 all the way to 8, and we were to add up all those probabilities, y'all, we would have gotten the number 1. Now, in part B, we actually found the probabilities for 6, 7, and 8. We got that number to be 0.011. So if I wanted to find this part here, we could just say, look, let's minus that 0.011 on both sides, and we get 0.989. And that's the same answer that we had right there. Hey, another way you can go about doing it, right? Another way we can go about doing this. Okay. All right, so y'all, let's go through. We got a couple more. Let's knock these out. We'll take a little break, and then we'll do 4-3 because it's pretty short, y'all. Okay, so the next part here says a test consists of 10 true or false questions. To pass the test, a student must answer at least 8 questions correctly. If the student guesses on each question, what's the probability that the student will pass the test? Okay, so y'all, I'm going to do my binomial distribution here. Let's remember our n is the number of trials, right? Depending on how your calculator is. So y'all, I think some of y'all, like in my calculator that I have here, I think the software is just not updated, so that's why mine looks a little bit different. But n, how many questions are they going to ask us? Anybody know how many questions we got? 10, right? Okay. Now, let's figure out our probability. Y'all, the questions are true or false. So it's either true or it's false. So if you guess, what is the probability you're going to get it right? 50%, right? Awesome, 0.50. Now, in order for us to pass this test, it says that we have to answer at least how many questions? 8, right? So I want to know what's going to happen if I get 8 questions right, okay? Now, let's go ahead and figure out this. So look, y'all, I'm going to go to my binomial PDF, where we have our n, our p, and our x. So we have 10 questions. The probability that we guess correctly is 0.5 or 0.50. and I need to get 8 questions right. So y'all, I'm going to come back this way. Again, I'm going to make sure that I hit binomial PDF, right? Let's scroll. Oh, too far. Boom, right there. And we're going to go 10, comma 0.5, comma 8. I'm going to hit enter. And y'all, I'm coming up with 0.044, right? So my probability 0.044. And y'all, I got another one similar to this, and it says find the probability of an individual, or the probability of an individual being left-handed is 0.18. So let's write some pieces of information down. My P is a 0.18. I don't really need to write the other 0. In a class of 57 students, okay, so look, y'all, my N is 57. What is the probability of finding 5 people who are left-handed? Any left-handed folks here today? No? So, all right, we don't got any left-handed folks here. So look, y'all, we're going to go again. Binomial PDF, okay? Remember, N, P, and X, okay? So we're going to go binomial PDF with 57 people, the probability being 0.18, and we're trying to find what's the probability that 5 people will be left-handed. Okay. Boom. So second in bars, right there. Let's scroll down a bit. Here we go. Y'all, I'm going to go 57, comma 0.18, comma 5. And let's close that up right there. And again, y'all, if I go to 3 decimal places, 0.026. Right? So when they're asking me to round to the nearest thousands, y'all, that means 3 decimal places, okay? Okay, so y'all, I just got a couple more to do. Let's knock these out. I think there's 3 more to do, a few more to do. Let's knock these out, y'all, and then we'll do 4-3. Let's take a look here. It says 59% of U.S. adults think that civil rights for Black Americans have improved in their lifetime. We select 10 adults. Find the probability of the number who think that civil rights for Black Americans have improved is exactly 1 and exactly 4. Okay, so look, y'all, let's do the first part. Find the probability that we get exactly 1. We're going to do a couple of things here, y'all. We randomly select 10 adults. So my N is going to be 10. The probability of people thinking that civil rights have improved is 0.59. Okay. So remember, y'all, we're going to go binomial, PDF, N, P, and X. So I'm going to go binomial PDF with 10, my probability being 0.59, and getting exactly 1 person. Okay. So I'm going to go second entry, and it's going to change my numbers up here. Whoa. Let's make that a 10. Let's make this a 0.59. And let's change that 5 to a 1. And we'll hit enter. And y'all, I'm coming up with 0.002. Okay. And my part B says exactly 4. So I'm still going to do the same thing with 10, 0.59, and 4. And we'll just change that last number to a 4. Boom, hit enter. And y'all, I'm coming up with 0.130. Okay. And we found our probabilities, right? So again, y'all, not too difficult to do. I think the binomial stuff is pretty easy in terms of how do you do this on the calculator, but those are basically the questions they're asking me to find. So let's try a couple more, y'all, and then we'll do something a little bit different. It says 45% of consumers say that it's important that the clothing that they buy is made without child labor. I would have hoped it would have been more than 45%, right? But that's what they're telling us. It says we randomly select 17 consumers. Find the probability that the number of consumers who say it's important that the clothing they buy that's made without child labor is exactly 7, at least 9, less than 10. Okay, so let's do the first part, y'all. And we're selecting 17 people. Our probability is a 0.45. Okay, probability of exactly 7. Y'all, this just means that my x is equal to 7. Okay. So again, I'm going to go binomial PDF with 17, 0.45, and 7. Change that to a 17. Oops. Change this to a 45. Change this guy to a 7. Okay. And y'all, I'm coming up with 0.184. Okay. So, y'all, let's take a look at part B. It says, find the probability of the number of consumers who say it's important that they buy clothing made with child labor is at least 9. Remember what at least 9 means, y'all? It means 9 or more. So we want to go all the way until we get to 17, right? Now, there's a couple of ways we can do this, y'all. We can find the probability of 9 and 10 and 11 and 12 and add up all those numbers. But the other thing we can do is we can say, look, if we took the probability of 0 plus the probability of 1 all the way to 8, all the way to 9, all the way to 17, if we added up all those probabilities, we would know that that would be equal to 1. Since, my friends, we are trying to find from 9 through 17, if we knew what this number was, we could say, well, the way we can find from 9 to 17 is find this number, subtract it from 1, and then we'll get our answer. And the way we can find this one, y'all, is we can say, let's use our binomial CDF with 17.45. And remember, I'm always going to use my last number right there, which is 8. And then I got to subtract that from 1, and that'll give me the rest, right? So instead of me having to go 9 and 10 and 11 and 12 all the way to 17, we can do it this way, right? So look, y'all, I'm going to go second bars. Remember, I'm going to go to binomial CDF, my friends. Number 11, okay? We're going to go 17, comma, 0.45, comma, and 8, okay? And I'm coming up with 0.6625. Now, remember, y'all, I want to take 1 minus that. So in my calculator, y'all, I'm going to hit 1 minus. The way I get to my answer, y'all, I can go second, and then the little negative button right at the bottom tells me whatever my answer was previously. And y'all, I'm coming up with 0.337. Okay, and y'all, part C, what's the probability that it's going to be less than 10? Remember, less than 10, y'all, would be 0 all the way up to 10. Again, we can come back one more time. Binomial CDF, 17. What was it, 0.45? Yeah, 0.45 and 10. And that's going to give me, I'm sorry, less than 10. Less than 10, I'm sorry, my mistake, y'all. What number was less than 10? 9. Sorry, thank you. Boom. So we don't want 10 or less, we want strictly less than 10. So let's go second bars. Let's scroll downstairs. Boom, let's hit this, 17, comma, 0.45, comma 9. Oops, sorry, I forgot my comma. Here we go. And y'all, I'm coming up with 0.817. There we go. Good, very good. Okay. So y'all, the last part that I have here is just talking a little bit about mean, variance, standard deviation. So we have some formulas for mean, variance, and standard deviation. And I got my formulas right here, y'all. So mean, our value of mu, which is the mean, is going to be n times p. My variance, sigma squared, will be n times p times q. And my standard deviation, y'all, will just be the square root of that. I'm going to show you how we can figure out how to do some of these things here. So let's take a look, and it says 74% of adults in a certain country believe that life in other planets is plausible. You randomly select 5 adults and ask them whether they believe life on other planets is plausible. The random variable represents the number of adults who believe life on other planets is plausible. Okay, find the mean, the variance, standard deviation for the variable and interpret the results. Okay, so let's take a look here, y'all. Everybody agree that our p-value is going to be 0.74? Remember, y'all, the way we find our value for q is we're going to go 1 minus p. So if I were to say, hey, what's 1 minus 0.74? My value of q, y'all, would be 0.26. And then our value for n was, how many adults did we select? Selected 5, right? Okay, so let's do this part. Let's find our value for mu, okay? Our value for mu, y'all, the average is going to be n times p. So it's going to be 5 times 0.74. So 5 times 0.74, 3.7. So on average, 3.7 people think that, yeah, life exists somewhere else. Okay. Now, let's find our variance. Y'all, the way we find our variance, sigma squared, is we're going to take n times p times q. So we're going to go 5 times 0.74 times 0.26. So times 0.26, 0.962. They are asking me to round to 2 decimal places, y'all. So I'm just going to put 0.96. Okay. Now, they are asking us to find our standard deviation. Y'all, the way we're going to find our standard deviation is we're going to take the square root of the answer that we just got, which was the square root of 0.962. So square root. And y'all, we are asking to go to 2 decimal places again. I'm coming up with 0.98. Okay, at rounding to 2 decimal places. Okay, so now let's see if we can figure out what they're asking me to do here. On the average, y'all remember the mean is the same thing as my average. So on average, y'all, we're going to go to 2 decimal places. Y'all, we're going to say 3.7. Right? Out of every 5 adults think that life happens other places. And the number of adults who think life on other planets is plausible would differ from the mean by no more than, that's my standard deviation. And again, right here, y'all, I'm just going to write 0.98. And that right there, y'all, is 4.2. Y'all, let's take like a 5-minute break. Let's come back 3:08. Okay, I know it says 3:02, but let's come back 3:08, y'all, and we'll do 4.3 and we'll call it a day. Again, I'm going to stop recording, but I will record back.